What if I told you that personal flying machines, real, full-size aircraft, inspired by the Jetson One, are now being advertised on Alibaba? Not toy drones, not scale models, and not futuristic concept images created to attract investors. These are electric multicopters designed to lift an actual human being into the air. Some are advertised for less than $50,000, and one seller even lists a production lead time of just 15 days. But there is an important distinction. 15 days of lead time does not necessarily mean the aircraft will arrive at your home in 15 days. It does not include international shipping, customs, registration, inspection, or certification. And an Alibaba listing does not automatically mean an aircraft is legal or safe to operate in your country. Still, the listings are real. The aircraft are being presented as products buyers can inquire about today. And compared with the Jetson One, the price difference is extraordinary. The Jetson One currently has an official price of $148,000, excluding taxes and other fees. Its entire 2026 and 2027 production is sold out, and new orders are being scheduled for estimated delivery in 2028. Meanwhile, several Jetson-style aircraft appearing on Alibaba are listed between approximately $38,000 and $68,000. That is not a small discount. In some cases, it is less than one-third of the price. In our previous video, we examined 3 Chinese companies developing personal flying vehicles with layouts remarkably similar to the Jetson One. Since then, the situation has escalated. More manufacturers have appeared. Prices have fallen even further, and several sellers are no longer presenting these aircraft as distant prototypes. They are presenting them as machines available to order. So, are we witnessing the beginning of affordable personal flight? Or are buyers being invited to become test pilots for an industry moving faster than its evidence? Today, we are examining the latest Chinese manned drones, what their sellers claim they can do, how much they cost, and the enormous questions their listings do not answer. Because the most important number is not the price. It is the number of safe flight hours these aircraft can actually accumulate. And right now, that number is almost impossible to find. To understand why these aircraft are appearing, we first need to understand what the Jetson One accomplished. The Jetson One did not invent electric vertical flight. Large drones had already demonstrated that multiple electric motors could lift heavy payloads. Experimental eVTOL aircraft were being developed long before the Jetson One became famous. What Jetson did was package the technology in a way that suddenly felt personal. One seat, an open cockpit, a lightweight frame, no runway, no conventional wings, and no large helicopter transmission. The aircraft looked less like a traditional aviation product and more like a machine from a science fiction film. It could take off from a small area, hover in place, turn inside a remarkably tight space, and fly between obstacles with the agility of an oversized camera drone. Most importantly, people could imagine themselves flying it. That is why the basic layout became so influential. From an engineering perspective, a multicopter has several attractive qualities. Electric motors can be controlled independently. The aircraft can roll, pitch, and yaw by changing the speed of different propellers. A flight computer makes hundreds of small corrections every second. The pilot does not need to control a complicated helicopter swash plate, tail rotor, and transmission. And multiple motors can provide some level of redundancy. For a small personal aircraft, this is a compelling formula. But it is also relatively easy to imitate visually. A tubular frame, a central seat, 4 arms, coaxial electric rotors, a joystick, a battery pack. Put those elements together, and the result immediately resembles the Jetson One. The difficult part is not making something that looks similar while sitting on the ground. The difficult part is building an aircraft that remains safe after hundreds or thousands of real flights. That requires structural testing, battery testing, motor out testing, software validation, fatigue analysis, maintenance procedures, quality control, and a complete record of what happens when something goes wrong. A design can be copied quickly. A safety history cannot. The rapid appearance of these machines is not happening in isolation. China is investing heavily in what it calls the low-altitude economy. This term covers economic activity connected to civil aircraft operating relatively close to the ground. That includes delivery drones, agricultural aircraft, inspection platforms, emergency response vehicles, air taxis, and passenger-carrying eVTOLs. The key difference is that China is not treating these machines as unrelated experiments. It is attempting to develop an entire ecosystem around them. Aircraft manufacturers, motor suppliers, battery companies, flight control software, navigation technology, takeoff and landing infrastructure, training centers, commercial routes, regulations, insurance, and public services. Shenzhen has formally established regulations supporting both piloted and unpiloted low-altitude flight, as well as aircraft research, production, sales, infrastructure, and flight services. The city has also introduced financial support for eligible eVTOL and large drone businesses, including incentives that can reach millions of yuan under specific conditions. This matters because aviation development is brutally expensive. A startup can build an impressive prototype and still fail before reaching production. Every new aircraft needs batteries, motors, lightweight materials, control systems, testing facilities, and specialized engineers. Then it must survive the certification process. Government support cannot make an unsafe aircraft safe, but it can help companies survive long enough to continue development. Shenzhen also offers another major advantage: supply chain density. DJI is headquartered there and says its location provides direct access to suppliers, materials, and engineering talent. That same manufacturing environment can also benefit smaller companies working on electric aircraft. Shandong is emerging as another important region. Qingdao, in Shandong Province, has introduced an official low-altitude economic development plan covering aircraft manufacturing, test zones, logistics routes, tourism services, and future eVTOL operations. This combination of policy support and manufacturing capability helps explain why so many new designs are appearing so quickly. But speed creates its own danger. When companies are rewarded for entering a fast-growing market, the number of products may grow faster than the amount of independent evidence supporting them. And that brings us to the first aircraft. The first model is the Eagle One, listed by Uwant Intelligent Technology. At first glance, the formula is familiar. A single seat sits inside an exposed frame. 4 arms extend from the center. Coaxial propellers provide lift. And electric motors eliminate the need for a conventional engine and mechanical transmission. The seller material featured in the original video described several control options: manual joystick control, autonomous flight, remote operation from the ground, and computer-based back-end control. In theory, multiple control modes could create additional redundancy. If the onboard operator becomes unable to control the aircraft, a ground station might take over. If communication with the ground is interrupted, the aircraft might continue through an autonomous mode. But the phrase, multiple control modes, should not be confused with proven safety. The crucial question is not whether those modes exist. It is how the aircraft behaves while switching between them during an actual emergency. Does control transfer instantly? What happens if 2 systems give conflicting commands? Can the remote connection be interrupted? Can the aircraft identify faulty sensor data? And which system has final authority? These are certification-level questions. A product page cannot answer them. The original seller material also described RTK and GPS navigation. RTK, or real-time kinematic positioning, can improve location accuracy by using correction data in addition to normal satellite navigation signals. For an autonomous aircraft, that could help with precise takeoffs, landings, and route tracking. The material also referred to a black box-style recording system. Again, that sounds reassuring. But a true aviation flight data system must do more than store basic telemetry. It must preserve information reliably, through abnormal events, and provide investigators with useful records afterwards. Then there is the structure. The Eagle One is advertised as using metal and lightweight materials, with aluminium and carbon fiber referenced in the original presentation. That is a logical combination. Aluminium is familiar, relatively affordable, and easy to manufacture. With carbon fiber can reduce weight in areas where stiffness matters. But the material name alone tells us very little. The important questions are how the parts are joined, how loads travel through the frame, and how many flight cycles the structure can survive before cracks begin to appear. Now we reach the number that will attract most buyers. The current Alibaba listing advertises a price of approximately $49,000 for one aircraft. That price falls to around $45,000 for 2 to 4 units, and $39,000 for 5 or more. For a single unit, the listing shows a lead time of 15 days, while shipping costs and delivery dates must be negotiated separately. That is why the 15-day claim must be treated carefully. It appears to refer to seller-reported preparation or production time. It does not mean the aircraft will clear customs and arrive ready for legal operation 15 days after payment. The current listing also claims a flight time of 30 to 45 minutes and a speed of 100 kilometers per hour. That is significantly different from the approximately 15-minute performance described in earlier material. And there is another problem. The same listing includes figures such as a 75-kilogram aircraft weight alongside a 600-kilogram takeoff weight and 600-kilogram safe load. And those numbers appear internally inconsistent for the type of aircraft shown. That does not automatically prove the aircraft is incapable of flight. It may be a translation problem, a listing error, or specifications copied into the wrong field. But when the product is supposed to carry a human being, inconsistent specifications are not a minor inconvenience. They are a warning. And the Eagle One is not the cheapest option. The second aircraft does not have a memorable futuristic name. It is listed simply as a single-person manned drone by BSM Industrial Manufacturing. The basic concept is again familiar. One seat, an electric multicopter layout, vertical takeoff and landing, and a flight control system intended to make the aircraft easier to operate than a conventional helicopter. The original seller material described a preset route function. According to that material, the operator could enter several waypoints and allow the aircraft to follow a predetermined path. This would make sense for controlled applications. A sightseeing route over private land, a repeated training circuit, a short demonstration flight between fixed locations, or an industrial operation where the route remains the same every day. The original presentation also stated that positioning combined GPS with China's Beidou satellite network. Using signals from more than one satellite constellation can improve availability and give a navigation system access to more satellites. However, those specific waypoint and Beidou claims are not clearly confirmed in the current public listing available through Alibaba's catalog. They should therefore remain described as seller claims from the earlier material, not independently validated capabilities. The information currently visible on Alibaba advertises approximately 15 minutes of flight time, a 100-kilogram payload, one seat, a 4K camera, and a maximum altitude figure of 120 meters. The advertised price range is approximately $38,000 to $41,000. That makes it one of the cheapest complete human-carrying aircraft listings in this category. At $41,000, it costs less than many premium cars. But aviation pricing is deceptive. The purchase price is only the first cost. A buyer may also need to pay for shipping, customs, batteries, charging equipment, replacement propellers, training, inspection, insurance, storage, maintenance, and potentially modifications required by local regulators. There is also a more basic question. Is BSM the actual aircraft designer and manufacturer, or is it acting as a marketplace supplier? The Alibaba catalog confirms that BSM is listing the aircraft. It does not, by itself, establish who performed the engineering, flight testing, and manufacturing. That distinction matters enormously. When something fails, who has the design data? Who issues maintenance instructions? Who supplies software updates? And who decides whether the aircraft should be grounded? A marketplace can connect a buyer and seller. It cannot replace a manufacturer's aviation support organization. Still, the price is impossible to ignore. If the aircraft performs as advertised, it represents a dramatic reduction in the cost of entering personal electric flight. But that "if" carries the weight of the entire machine. The third aircraft was introduced in the original material as the Cloud Whale, developed or marketed through BJZ Technology Development. Current marketplace search results also show aircraft using the name Cloud World, with several visually similar human-carrying drone listings appearing at different prices. This is the first complication. Names, suppliers, and prices can change across listings, and that makes it difficult to establish whether every page refers to exactly the same aircraft. The original video cited a price of approximately $68,415. Current Alibaba search results show Cloud World branded manned aircraft in ranges beginning around $39,000, while other pages show figures from approximately $53,761 to $67,547. That variation may reflect different configurations, different sellers, different quantities, or simply changing marketplace listings. The aircraft's appearance is more utilitarian than the Jetson One. Instead of looking like a minimalist recreational vehicle, it resembles a machine built around a central equipment structure. The original seller material claimed a similar flight duration to the other models and emphasized two major features. The first was RTK positioning. The second was 360-degree obstacle avoidance. Both sound extremely valuable. These aircraft are designed to fly at low altitude, where the sky is anything but empty. Trees, buildings, power lines, poles, antennas, fences, birds, vehicles, and people. A conventional aeroplane usually operates from a runway and spends much of its journey far above small obstacles. A personal multicopter may spend almost its entire flight close to them, but obstacle avoidance becomes much harder when the drone carries a human. A small camera drone may weigh less than 2 kilograms. It can stop quickly, change direction rapidly, or survive a minor collision without causing a catastrophe. A manned aircraft may weigh hundreds of kilograms when loaded. It has far more momentum. By the time a sensor identifies a cable or branch, the aircraft may not have enough space to stop. A true 360-degree system would therefore need more than sensors. It would need reliable detection, accurate distance measurement, fast processing, safe decision-making, and enough thrust to perform the avoidance maneuver. Rain, glare, darkness, dust, and fog could all affect performance depending on the sensor technology used. So the important question is not, Does the aircraft have obstacle avoidance? It is, under exactly which conditions has that system been tested? Without independent validation, we do not know. And that uncertainty becomes even more serious when the aircraft is marketed for terrain such as valleys, forests, mountains, and search and rescue operations. Those are precisely the environments where navigation and obstacle sensing are most difficult. The next aircraft is the David II, associated in the original material with Sky eVTOL. Unlike the Alibaba listed machines, a clear current price was not provided. But the David II stood out for a different reason: its safety and training ecosystem. The original company material described a ballistic parachute system. In an emergency, a rocket-assisted or rapidly deployed parachute could potentially lower the entire aircraft to the ground. For a multicopter, that is an attractive idea. Unlike an aeroplane, a compact multicopter has little or no ability to glide after a total loss of power. If all lift disappears, gravity takes over immediately. A whole aircraft parachute could create an additional layer of protection. But parachutes have limitations. They need time to deploy. They need enough altitude to inflate. The aircraft must remain structurally intact, and the parachute must not become entangled with the rotors or frame. A system that works at 100 meters may be useless during a failure 10 meters above the ground. That is especially important because recreational personal aircraft are often flown low, near trees, above fields, or around private property. In those environments, a failure may occur below the minimum effective parachute height. The David II material also described a dedicated simulation platform, including a 180-degree immersive simulator. This may be more important than it first appears. The public often assumes multicopters will require almost no training because computers stabilize them. But stability does not eliminate judgment. A pilot still needs to understand weather, battery reserves, emergency warnings, landing site selection, rotor hazards, weight limitations, and the effect of temperature on performance. The most dangerous moment may not be when the aircraft malfunctions. It may be when an inexperienced owner decides to fly in conditions the aircraft cannot safely handle. A simulator allows a user to experience emergency scenarios without risking an actual aircraft. Motor failure, navigation loss, unexpected wind, a rejected landing, low battery, or a forced descent. A manufacturer that thinks seriously about training may ultimately create a safer product than one that focuses only on maximum speed and dramatic promotional flights. But once again, the challenge is verification. The supplied material describes the parachute and simulator. It does not provide independent certification data, deployment test results, or a public operating history. The idea is promising. The evidence remains limited. The final notable aircraft comes from Yifang Aviation. The original material described it as a high-agility eVTOL, using 6 coaxial rotor positions instead of the more familiar 4-position layout. Visually, that creates a larger and more complicated machine. But it may also offer an aerodynamic advantage. To understand why, we need to talk about disk loading. Each rotor sweeps through a circular area. Together, those circles form the total rotor disk area supporting the aircraft. If the same aircraft weight can be distributed across a greater total disk area, the rotors do not need to accelerate the air downward as aggressively. In theory, that can reduce the power needed to hover. So, if the 6-position design increases total rotor area without adding too much weight, it could achieve lower disk loading than a 4-position design. That might improve hover efficiency. It might also provide more control authority and additional motor redundancy. But adding 2 more rotor positions does not automatically make the aircraft more efficient. The new arms add structural weight. The extra motors require controllers, cables, and mounting hardware. More components create more maintenance points. And because the rotors are coaxial, the lower propeller in each pair operates inside airflow already disturbed by the upper propeller. That interaction creates efficiency losses. Therefore, the correct conclusion is not, 6 rotors are more efficient. It is. A 6-position layout could reduce disk loading if the increase in rotor area outweighs the added weight and coaxial interference. Without published dimensions, weight, battery capacity, and measured power consumption, we cannot calculate the real benefit. But the design remains one of the most interesting in the group. It represents a company attempting to move beyond a direct visual copy of the Jetson One layout and experiment with a different balance between compactness, redundancy, and efficiency. Whether it works better can only be determined through comparable testing. Same payload, same battery reserve, same weather, same flight profile, and independently measured endurance. Until that happens, the extra rotors are an idea, not proof. When these newer aircraft are added to the 3 Chinese machines discussed in the previous video, the original tally rises to at least 8 advertised or announced Jetson-style alternatives. That number will probably continue changing. Alibaba search pages already display additional single-seat eVTOL and human-carrying drone listings at prices below $50,000. Some are complete aircraft listings. Others may be suppliers reselling the same design under different names. And some may represent machines still transitioning from prototype to production. This creates the illusion of a large, mature market. But 10 listings do not necessarily mean 10 independently engineered aircraft. 2 suppliers may be advertising the same platform. A company may show images from another manufacturer. A marketplace page may remain online after the product changes. Specifications may be copied from an earlier listing, and the same aircraft may appear under several different product titles. That is why counting listings is easier than counting real manufacturers. Even so, the trend is clear. The Jetson One no longer stands alone as the only recognizable one-seat personal multicopter being offered to private buyers. A broader market is forming around the concept, and competition is pushing advertised prices downward. But price is not the only area where the Chinese listings appear more attractive. Availability may be an even greater advantage. Jetson's official order page says current customers are reserving aircraft for estimated delivery in 2028. The company states that its 2026 and 2027 production is already sold out. That waiting list shows strong demand. It also creates an opportunity for competitors. A potential buyer may love the Jetson One, but be unwilling to wait 2 years. Then that buyer finds an Alibaba listing offering a visually similar aircraft for 1/3 of the price and a stated lead time of 15 days. The temptation is obvious. But those 2 timelines are not directly comparable. Jetson's estimated delivery date refers to a place in its production schedule. The Alibaba lead time may refer only to preparation by the seller. It does not include shipping to another country. Aviation batteries can create complicated transport requirements. The aircraft may need to travel by sea. It may need to be partially disassembled. Customs documents must be completed. The buyer may have to arrange specialized unloading. And once the crate arrives, the aircraft may still require assembly, inspection, and configuration. Then comes the biggest challenge: permission to fly. An aircraft being physically present in your garage does not mean it can legally enter the sky. Regulations vary by country. The aircraft's weight, speed, operating altitude, and construction may determine whether it can qualify under an ultralight category, or whether it requires registration, certification, or a pilot license. Local authorities may restrict where it can operate. Insurance companies may refuse coverage, and a product built for one regulatory environment may not satisfy another. So the real delivery date is not the day the crate arrives. It is the day the aircraft can be operated safely and legally. For some buyers, that day may be much later. For others, it may never come. When people compare these aircraft, they normally focus on 5 numbers: price, flight time, maximum speed, payload, and delivery time. But those numbers may not be the ones that decide whether the aircraft is useful. Consider battery life. The seller may advertise 15, 30, or 45 minutes of flight. But under what conditions? With what pilot weight? At what temperature? At what altitude? With a brand new battery? Was the aircraft hovering in ground effect? Was there a required landing reserve? And how much endurance remains after 200 charging cycles? Then consider motor redundancy. If one motor stops, can the aircraft remain level? Can it maintain altitude? Does it land automatically? Or does the flight controller simply prevent an immediate loss of control while the aircraft descends? Those are very different outcomes. What happens if a propeller blade develops a crack? What happens if the GPS signal disappears? Can the aircraft maintain position using other sensors? What happens if one battery cell overheats? Are the battery modules isolated from each other? Does the system detect a thermal event before it becomes a fire? How frequently must the propellers be replaced? Are replacement motors available? Can the owner perform maintenance? Or must the aircraft be returned to China? Who installs software updates? Can the aircraft still fly if the manufacturer's servers disappear? These questions rarely appear in marketplace advertisements, but they are the questions that determine long-term ownership. A personal aircraft is not a consumer gadget. It cannot become unsupported after 3 years and still be considered safe. The owner needs manuals, inspection intervals, approved replacement parts, service bulletins, software records, and access to engineers who understand the machine. An affordable purchase price loses its appeal very quickly if one damaged component grounds the aircraft for 6 months. It would be easy to look at the prices and conclude that the Jetson One is simply overpriced. But that comparison ignores what customers may actually be paying for: brand visibility, public testing, documented development, a clearer production program, customer support, and confidence that the company will still exist when maintenance is required. That does not mean the Jetson One is perfect. Its price is high. Its flight time remains limited. Its open cockpit and exposed rotor architecture will not appeal to everyone, and a long waiting list creates frustration. But reliability has value. A manufacturer that spends years testing an aircraft may appear slow compared with a company promising delivery in weeks. In aviation, slow is not always a weakness. Sometimes slow is the visible result of discovering everything that can go wrong. Chinese manufacturers could eventually prove that they can offer comparable reliability at much lower prices. China has already demonstrated extraordinary ability to reduce manufacturing costs in industries including drones, batteries, and electric vehicles. But personal aircraft create a different standard. A faulty phone is annoying. A faulty aircraft can be fatal. That is why the cheaper machines should not be dismissed. But they should not be trusted automatically either. They need the same thing every successful aircraft needs: evidence, not renderings, not product pages, not perfectly edited demonstration flights. Evidence accumulated over time. Eventually, one of these manufacturers will deliver multiple aircraft to real customers. Those machines will begin flying outside the company's demonstration site. Different pilots will use them. Different climates will stress them. Some will land harder than expected. Some will be flown in wind. Some batteries will age. Some sensors will fail. Some owners will ignore instructions. And that is when the real test begins. Can the aircraft survive ordinary human behavior? Can it accumulate 1,000 flight hours without a serious structural problem? Can it perform hundreds of battery cycles without a dangerous loss of endurance? Can it tolerate a motor failure? Can it detect maintenance problems before they become accidents? Can the manufacturer respond quickly when a flaw is discovered? A prototype is built to prove that flight is possible. A production aircraft must prove that safe flight is repeatable. Again, and again, and again. This is the difference between an exciting machine and a transportation product. The companies that succeed will not necessarily have the most dramatic design. They may not offer the lowest price. They may not claim the longest flight time. They will be the companies that create boring reliability, predictable takeoffs, predictable landings, clear maintenance, accurate specifications, and no surprises. When personal flight finally becomes normal, nobody will gather around every time one of these aircraft leaves the ground. People will stop looking. That is the moment the technology truly succeeds. Jetson ONE-style aircraft are now being advertised on Alibaba at prices far below the official cost of the Jetson One. One Eagle One listing starts at approximately $49,000 for a single unit and falls to $39,000 for larger orders. BSM listings appear between approximately $38,000 and $41,000. Cloud World-style aircraft appear across several listings with prices that vary significantly. And more designs, including aircraft with parachutes, simulators, and 6 coaxial rotor positions, are being promoted or prepared for future release. That is real progress. It demonstrates that the personal multicopter concept is spreading, manufacturing competition is increasing, and China's low-altitude economic strategy is helping create an environment where new aircraft can appear at remarkable speed. But it also creates a dangerous illusion. The illusion that a low price means the hard part has been solved. It has not. The hard part is not building a machine that rises into the air once. The hard part is building a machine that can do it thousands of times, with different pilots, in different conditions, without turning one hidden weakness into a catastrophe. A 15-day lead time is impressive. A $40,000 price is disruptive. Autonomous flight, RTK navigation, obstacle avoidance, and ballistic parachutes all sound reassuring. But only real-world operation will reveal what those features are worth. For now, the Jetson One has something most of these alternatives do not: a recognizable name and a more visible development history. The Chinese aircraft have something Jetson does not: aggressive pricing and the promise of much faster availability. Eventually, the market will decide which matters more. But the final decision will not be made by the cheapest listing. It will be made by reliability, by battery records, by maintenance data, by motor out tests, by accident reports, and by the experiences of the first customers brave enough to climb inside. So, would you trust a personal aircraft ordered through Alibaba? Would you choose the Eagle One at approximately 1/3 of the Jetson One's price? Would you prefer the BSM model with its advertised 15-minute endurance? Or would you wait for the six-rotor aircraft and hope its larger disk area delivers better efficiency? More importantly, how much independent testing would you need to see before placing your life beneath those propellers? Let us know in the comments. And if you enjoyed this video, subscribe for more stories about personal aircraft, eVTOL technology, and the rapidly changing future of aviation.